Hello viewers, welcome back. So I have completed common blocks.py and now I will be creating another py file. So Ctrl S, named it as model.py. Now I have to import Tensorflow, STF, then import common blocks. So from common blocks, I'll be importing darknet 53. So you can see I have this function out there, darknet 53 res block, then convolutional block. So these functions I will be importing. So import convolutional, then import res block. Okay. So and I have upsample, import upsample. Now I will be needed of import NumPy as np, then okay, so these are the things will be needed for now. So def, now I'll be defining Yolo V3 and give out their input layer. So input layer and the root 1, root 2, then input layer, sorry, conf, write out the conf so that contradiction do not work out. Now darknet 53 and pass out their input layer. So okay, now if you see out there, if you see the figure, I have completed the darknet structure. Now I have three outputs. So this is one of the output here, and this is another output, and this is another output. Now I will be going for some convolutional layers, then I will be getting another three outputs. So let's go. Conv equal to convolutional, write out there conv, pass out there 1 1 1 0, oh sorry, 1 0 2 4, pass out there 512. Okay, so just write this 4 line of code by yourself. Now conv large opt branch equal to convolutional, then I'll be passing conv out there and give out there 3 by 3 filters and 512 channels and give out there 1024 filters, and after that I'll be conv large box bb box equal to convolutional and pass out there conv large box out there and give out there 1 comma 1 comma 1 0 1 0 2 4 and 3 into number of classes. So write out there number of classes. So what are the number of classes? So let's say I have 80 type of objects and I want to classify them. So for that reason I have to define a variable out there, number of classes equal to 80. Now so 3 is the number of anchor boxes, and okay, so n plus 5 I have to apply out there 5. So for every prediction there will be 85 elements. For the first 4 will be the coordinate of box, and the fifth one will be the probability of having any object, and the rest of the 80 will be the probability of being a particular object. So now I have to give out their activation. So give out their activation. So activate equal to, I'll be false, putting out their false. Then batch norm equal to false. Okay, so now convolutional equal to I'll be passing then give out there 1 comma 1 comma 512 and 256 out there. Now out there upsample, so pass out there upsample and give out there okay. Now I am going to Tensorflow. Okay. So if I show you the architecture here, so I am done with one of the uh, convolutional output. This is for the large object, and this line out there, so these are the for the large object predictions, large object, not large object, large mesh prediction. And here you can see from here I will be having an input, and from here I will be having an input, and after passing some convolution, then I will be concate them, then I will be go for further convolutional layers, and I will be having the medium size mesh prediction. And so this is what I am doing now. So let's go. So concate them, conv root 2, give out their axis of conv, give out their root 2 and give out their axis of -1. So concatenation is finished. Now I'll be going for convolutional layer. So convolutional layers out there, conv and 1, 1. So just write these 5 convolutional layers, 1, 2, 3, 4, 5, and match the number of filters. Okay, so okay, now conv branch, I'll be having again convolutional. Now give out their conv and pass out their 3 by 3 filters and 256 of channel and 512. Now I am going to conv medium object box equal to go out their convolutional, pass out their conv medium object branch and give out their 1 by 1 filter and 512 channels and 3 into num of classes plus 5. Okay, so these are the number of filters which I am going to use in the last convolutional layers. So now I am done with the medium size object 2. So now I have to conv I have to pass out their activate equal to false. Now batch norm equal to false. So if I show you the picture, and you can see I am done with this y1 and y2. Now I have to find the y3. For that reason I have to go for further convolution. So conv equal to go out there convolution. So convolution now, and pass out their conv and give out there 1 by 1 by 1 256 channel and pass out their 128 filters. Okay, so okay, now I have to do some upsampling. So upsample equal to pass out their conv. Now conv equal to I'll be concate. So concate out there equal to pass out their conv. So conv and pass out their root 1 and give a axis out there. So axis equal to -1. Now conv equal to convolutional. So conv, so I'll be, so just complete this 5 line of convolution by yourself. Copy from here, and for your information I am already giving the GitHub code in the description, so you can check out there. Now conv small object branch equal to convolutional and pass out their conv and give a filter of 3 by 3 128 and 256 out there. Okay, so after that now I'll be conv sbb box equal to convolutional and pass out their conv small box branch and give out their filter of 1 comma 1 and 256 and give out their 3 into, so 3 is the number of anchor and num of classes plus 5. Okay, so now all I have to do, give out their active, so active equal to false. Now batch norm equal to false. So now I have to return, so return make a array, so conv small box, then just svb box, pass out their conv medium box, okay, then conv large box. So I'm done with another function, that is Yolo V3. Now I have to decode them. So for that reason I am defining another function, define decode equal to, so from each of these convolutional output I will be decoding them individually. So decode them, so decode conv out equal to, just keep default I equal to 0. Now conv shape equal to Tensorflow shape conv out, then base size, give out their base size out there equal to, so conv, where I was, so conv shape, so I will be using shape 0 equal to base size and output size, so output size equal to conv shape of 1. Okay, now I have to define conv output equal to Tensorflow reshape, so I'll be reshaping this function on output, on out, then I'll be passing here base size, so base size comma output size comma output size, and I'll be giving 3 anchors and then 85 predictions. You can define it like this one: num of classes plus 5. Okay, so these are the things. Now I can get conf raw dx dy equal to conf output. Then I want to write out there. So these are the base size, all the base size, then all the branch size, branch size, output size, then all the anchors. Then I'll be dividing this into 0 to 2. So first two element of 85 element will be the dx and dy. So on raw dw dh equal to, and again on output, so I'll be using output and give out there. So 2 to 4 elements will be the width and the height. So conf raw confirmation. So oh sorry, so conf raw conf, so conf output again. So I'll be having 4 to 5 element. So this is the fourth element actually. So conf raw and pop. So probability of 80 classes. So conf output, then go over there and 2 3 4 1 2 3 4. So put over there commas 1 2 3 4 and give out there 5 to ending. So now I want to, so basically if I see one picture, let's show. So let me show you this picture. So for every box out there I'll be having 85 output, and for the first two output will be dx and dy, and the second two will be dw and dh, and then confirmation, and after that the probability of each of the 80 classes. Now the after convolution I will be having output for only dx. That means I will be having the delta x. Okay, delta x means I will be having only the difference. So for finding x with respect to this corner, let's say this is 0 0 out there, so I want to find x with respect to this corner. Okay, so for that reason I have to do the decoding. So let's go forward. And so this is the model out there. Now I have to make a grid out there. So xy grid, make out there Tensorflow concat, and pass out there x, pass out there. So this will be a long command. Just so I have copied these three line of code, and basically what they are going to make. So if I see the picture out there, so this is a 13 by 13 grid out there, and for this one I am going to make a array of 0 0. Okay, and for this box I'll be going to make an array of 0 1, and for this one 0 2 0 3. So if I multiply delta x with that, then I will be having I will be having x according to that coordinate 0 0. Then I have to also multiply with the stride, so that I can get the actual what should I say, pixel. Okay, so let's go. So print xy equal to sigmoid const row, so delta x delta y. So the row delta x and delta y will be passed through a sigmoid function. So if I show you the figure, so I think this figure out there will make your concept more clear. And you can see this is a box and this is prediction, and for having b of x, okay, I have to pass through a sigmoid function to t of x, then sum that with c of x sigmoid function, and for getting the width I have to pass through the probability and and through exponential function, and here also probability into a exponential function. So this is what I am going to do in the next few lines. So pass xy grid, so pass their xy grid out there, and now I have to multiply the whole one with stride. So strides, stride, strides of I. So what are the strides? So just define strides, and okay, am I right? So there is an extra bracket out there. Just cut this out. I think everything is fine. So I have to define strides. So let's go upward and define strides equal to make an array. So I'll be using a NumPy array to make the strides. So NumPy array, make out there 8, 16 and 32. Okay, so for the smallest mesh I have stride of 8, and for the medium size mesh I have stride of 16, and for the largest size of mesh I have 32 strides. So this is what I have defined. Now okay, so I have to write the next few codes. So print wh equal to tf dot exponential, and pass the con row x row dwdx, and I want to multiply them with anchors. So what are the anchors? So again go for anchors, 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 and I, okay, I will be explaining the anchors. Just wait. Strides, source of I. So I'll be giving a link of anchors so that you can just understand the anchors. So this is the anchors which I am going to use. So the anchors which I am going to use is 1.25. so I want to reshape them. So anchors equal to numpy dot array. So anchors dot reshape them 3 by 3 into 2. So these are the box shapes, okay, out there. Now I am done. So if you want to copy, these are the anchor points, and you can copy from here, or you can go to the GitHub link so that you can copy. So now I am almost done with the decoding. Now all I have to do, just too few lines. Now I want to concat. So print xy wh equal to Tensorflow concat out there, and pass out there read of xy and read of wh, and give out their axis of -1. So axis of -1. Now read conf equal to tf.sigmoid and conf raw confirmation. Similarly for read probability, I'll be passing another sigmoid function over there, so sigmoid, and pass out there conf on raw probability. So return whole with Tensorflow concat, and I'll be concatenating the whole read xyz xywx, then read conf, then read probability, and I want to give an axis -1 out. So I am done with decoding and down with Yolo V3. On the next tutorial, I'll be showing you how to make the model. So this is all for this tutorial. Thanks for watching.